Alright, welcome back to my channel. And if this is your first time here, welcome. Today we will be talking about integration by parts. By the end of this video, you know what integration by part is, you know when you will use integration by part, and more importantly, you will know how to use integration by parts. Let's dive into it. Integration by parts is an integration technique that you use for integrating a function that is a product of two functions, and those two functions might not be related to each other. If you have two functions that kind of like related to each other, you might consider using U substitution. So what is the formula of integration by part? Here's the formula. It's integration of u dv is the same thing as uv minus integration of v du. When we'll be using integration by part to your problem, left hand side will be your question and right hand side will be your progress, or it might even be your answer. Integration by part formula is actually pretty easy to memorize. It's just integration u dv is the same thing as uv minus integration of v du, but how to use it is actually the hard part. So let's explore a little more how to use integration by part. So as I say, left hand side will be your question. So the first step to do is to assign which part of your function to be u, which part of your function to be dv. In order to understand how do you select part of your function to be u and dv, let's understand the nature of the formula of integration by part. So these are left hand side of your function. Sometimes you think of it as what you have, and right hand side you can think of it as what you want. You have u, you want u and du at the end. So during the process of integration by part, u will be transformed into u and du. On the other hand, you start off with v, you want to end up with v, which means part of your function that you assign to be u, you need to differentiate it. For dv, you start with dv and you end up with v. That means part of your function that you assign it to be dv, you will need to integrate it. So the rule of thumb is, in order to decide which part of your function to be u and which part of your function to be dv, you select part of your function that you want to differentiate to be u, and select the part of your function that you want to integrate to be dv. Right? Easy to differentiate to be u, and easy to integrate to be dv. So let me just say that there are mnemonics out there that tell you, you just go down to the list and whatever comes first in the list you select to be u, whatever comes last to be dv. That doesn't really tell you why you select something in that order though. This tells you precisely why you select certain thing to be u, select certain thing to be dv, and here's the reason why. By looking at the formula, you want to select the part that's easy to differentiate to be u, easy to integrate to be dv. Right, let's look at some example. Alright, so let's try to integrate this function together. Integration of x sine x dx. When you look at x sine x, so first question that you want to ask is, which part of x sine x you want it to be u, which part you want it to be dv. Let's think about that a little bit. So your function consists of two parts, x and sine x. So we ask, what happens if you differentiate x, what happens if you integrate x, and same question for sine x. For x, you differentiate it, you get 1. You integrate it, you get half of x squared. Right? So from point of view of x, if our decision based solely on choice of x, then we would rather differentiate x because function 1 is pretty easy to look at as opposed to function a half of x squared. So if we can choose just depend on x, we're going to differentiate x rather than integrate x. But that also depends on what happened to the other part of your function. So let's look at sine of x. Derivative of sine of x is cosine of x, and antiderivative of sine of x is minus cosine. So from point of view of sine of x, on one hand you get cosine, on the other hand you get minus cosine. So from this point of view, it doesn't really matter which one do you do, integrating or differentiating. Both give you equally easy or equally hard of the function to deal with. So sine of x would say, it doesn't matter, it's your choice. X say, okay, if it's my choice, I pick myself to differentiate. And sin of x, okay, if you differentiate, I'm gonna integrate. So it's going like this. Of course, referring back to the chart, to differentiate, you select that part to be u. Sin of x, you want to integrate it, so you select that part to be dv. Once you have decided which part to be u, which part to be dv, you need to write it down explicitly. So you select x to be u, and you select sin of x to be dv. And remember, whenever you have d on one side, you write d on the other side. dv is going to be sin x dx. Once you have written down your choice of u and dv, you write down their counterparts, which means write down du and write down v. In this case, if u is x, du is just dx. dv is sin x dx, so antiderivative of sin x is minus cosine. And once you reach this step, all you need to do is just plug everything into integration by parts formula and see what happens. On the left hand side, you have u dv. On the right hand side, you have u and v and v du. Once you reach this point, you still have integration sign on the last term, and what you hope is this part is easy to deal with, and by just eyeballing at this function, it's just cosine, right? So integration of cosine gonna be sine of some sort. So we have 2 minus sine here. 2 minus sine become plus. Antiderivative of cosine is just sine. And just don't forget to plus c at the end. And that shall be your correct answer. Let's do a couple more examples together. Alright, here's our second example, integration of x ln x dx. So again, first step to do is you ask which part of your function you want it to be u, which part of your function you want it to be dv. So we ask, what happens if we differentiate and what happens if we integrate each part of your function? In this case, x will become 1 if we differentiate it, and it will become half of x squared if we integrate it. So this is exactly the same as the previous example. X would say, if I can choose, I would rather differentiate. Integrating make my life harder, but that also again depends on ln of x. So let's dive into what ln of x has to say. Derivative of ln x is 1 over x. Antiderivative of ln x, we don't know, right? This is not something on your formula sheet that you need to memorize or anything. So we don't really know what antiderivative of ln of x is. So ln of x would say, look, I can't really integrate. I need to differentiate. There's no choice around it. Then x would say, fine, if you really want to differentiate, I can integrate. So it goes like this. Referring back to the chart, you see that part of your function that you integrate, you will assign it to be dv, and the other part that you will differentiate, you will assign it to be u. Alright, so let's write it down. Alright, u is ln. So counterpart of that is du, which is 1 over x dx. dv is x dx, so v is x squared over 2. Then you combine everything to integration by parts formula. Left hand side should be the same as your original question. uv will be just ln x and x squared over 2, and minus integration of v du, which just be x squared over 2, 1 over x. Alright, and moment of truth once again. You hope that this part that you left to integrate is easy to deal with. Right? So by eyeballing this, you have x squared over 2 here, you have 1 over x here. So in total, you will have x over 2, which is nice. You know how to integrate x over 2. This guy becomes x over 2. And of course, antiderivative of x over 2 is x squared over 4. And don't forget to plus c, and that shall be your correct answer. Alright, that's all I want to talk about today. Please leave a comment down below if you have any question, and if you haven't done so already, please consider subscribing so you will not miss my next video on math tip and trick. For now, thank you for watching. My name is Guang. Peace.